Section 2.11, bond length. So this table shows you some equilibrium bond length of diatomic molecules. So let's look at this too, H2 plus with a bond order of 0.5. This H2 has a bond order of 1. So this is a stronger bond, this is a weaker bond, stronger bond is shorter. Now let's compare this two. Both have a single bond, but fluorine is bigger than hydrogen. Therefore, this bond length is greater than the hydrogen 2 bond length. And now iodine is bigger than bromine, bromine bigger than chlorine, chlorine is bigger than fluorine. Therefore, the bond distance of HI is greater than HBr, HBr is greater than HCl, HCl is greater than HF, or single bonds. Now let's look at different bond orders. Nitrogen 2 has a triple bond. The bond length is short. O2 double bond with a longer bond length. F2, a single bond, longer the bond distance. Remember, if we're talking about atoms, nitrogen is bigger than oxygen, oxygen is bigger than fluorine. So the single bond between two nitrogen atoms is longer than the single bond between two oxygen. The single bond between two oxygen is longer than the single bond between two fluorine. But now we're looking at a triple bond, a double bond, a single bond. That's why in N2 the bond distance is shorter than O2, than F2. Now let's compare F2, CO2, iodine 2. They're in the same column, and therefore we can just look at the number of shells. The principal quantum number n, this is in the second row, this is the third row, bromine is in the fourth row, and then this is the fifth row. So we have this increasing order of bond length. If we have bromine 2 here, it should be between chlorine 2 and iodine 2. And then let's look at the table of covalent atomic radius. This hydrogen has a 37 picometer atomic radius. This is because, look at this, 74. We divide this by 2, we get 37. That's hydrogen. How do we get fluorine? Same thing. Well, we just need to look at the fluorine 2. This divided by 2, you get 72 picometers. 1 picometer is 0.01 angstrom, or 10 to the power negative 12 meters. Another way to look at the atomic radius of fluorine is from here. So we know the atomic radius of hydrogen is 37 picometers. So why don't we just use this minus 37, and then we get 55. From here we get 72. From here we get 55. So let's look at the fluorine number. 64, it's in the middle. The reason we get 55 here but 72 here is because over here there's a fairly strong ionic character here. Although this is a covalent molecule, but because of the large electron negativity difference, fluorine is 4.0, hydrogen is 2.1. So the difference in electron negativity is 1.9. So this molecule contains a lot ionic character, and that makes the bond stronger and shorter. When you have a stronger and shorter bond, we use this number, we get a shorter fluorine atomic radii. Again, if you use 92 minus 37, you get 55. You use this one divided by 2, you get 72. So that's right here. How do we determine the atomic radius of carbon? There are many ways. If you look at the ethane molecule, you can just measure the bond length between the two carbon atoms. It's 154 picometers divided by 2. 154 divided by 2, that's 77. But also you can use methane. And look at the carbon-hydrogen bond distance, that's 1.1. 1.1 angstroms, or 110 picometers. Minus 37, I think you'll get 73. So, well, it's pretty close. And because there are so many ways to determine the covalent atomic radius for the atoms, so sometimes you see different numbers. Well, they are close to each other, but still they are different.